This is Projected Consulting. I want to welcome you to our Stata online webinar for research analysis. This training is exclusively designed for lecturers, researchers, postgraduate students, professionals who want to unlock the power of Stata for statistical data analysis. Okay, if you have not really come across our company, Projected Consulting Limited assists individuals and organizations to implement the latest technology tools in business intelligence, data analysis, and project research development. We can also deliver classroom or online training experiences on any of the following courses. We have data analysis with SPSS, eView, Stata, R, Python, Amos, and Advanced Excel. We also offer the following services, including research consultancy services, thesis writing, proofreading, and editing of your work. We also carry out data analysis, and we also carry out data vendor in case you need data, and we can also provide any kind of data for you. We also do plagiarism testing. My name is Okoro Chukwemeka, the presenter. I also want to encourage you to visit our YouTube channel and our Facebook to like and follow our channels on social media. I also want to recommend some book here if you want to know more about data analysis with SPSS and eView. So we have a book. You can go to Amazon and buy the book on Amazon, or you contact us so that we can waybill the book to your location. So the agenda for this online starter training today, we are going to cover a whole lot of topics. So including uploading data into Stata, coding research questions into the software, understanding data types, defining value label, coding missing values in Stata, understanding inferential statistics, including the hypothesis testing, p-value, level of significance, decision-making interpretations. We'll also treat independent sample t-test, chi-square correlation analysis, including their interpretations. So we have uh, two major type of data here, the continuous data and the categorical data. The categorical data is subdivided into the nominal and the ordinal data, and being able to identify this data is very important so that um, you will be able to choose the appropriate analytical technique if you know the data type very well. So here I'm going to talk about the scale data. This data is the kind of data in which one unit change in numeric value represents the same change in quantity. It is a data that has a meaningful distance and a meaningful count. Meaningful distance and a meaningful count. If I count the number of persons in this training, I'm going to count, and I'm going to have a figure which is 2 or 3 or 4. So such kind of data is a continuous data, also known as numeric data or scale. If I measure the length of my table, I'm going to have the 4 feet or 5 feet as the case may be. So that is a number. If you measure the height of a human being, you're going to see that it is 5 feet or 6 feet. Number of students in a hall, exam score can be 30% or 40. So any number that varies from 0 to infinity is a continuous data. Data that varies from 0 to infinity is a continuous data, and such kind of data are numerical. So they are known as scale data. So that's it. So anytime we are measuring data in your research analysis, your data, and you come across a number, you know that that data is in this category, which is scale data. So the next one here is the nominal data, which is under the categorical data. We have that a nominal data that each value represents a category. Each value represents a category. Responses are divided into 2 or more distinct categories. Anytime you make your questionnaire and people respond, and such responses are in distinct categories. Distinct categories. What that means is that there is no inherent order in the categories. They are distinct on their own. There is no orderliness in that category. So when you have such kind of responses, you know that you are dealing with nominal responses. You are dealing with nominal responses. So example here is male or female. These are distinct categories. They are 2 different categories. We have tribe. We also have a yes or no, old or young. For tribe, you can have different tribes. So these are distinct categories. There is no inherent order in the categorization of a nominal data. So anytime you find your responses in this way, you should know that it's a nominal categorization. For example, let me make this questionnaire. For whom did you vote for in the 2019 presidential election? Option number A is Jonathan, and number B is Buhari. Now, these are options in nominal categories. There are 2 distinct categories. There is no orderliness in the categorization. So such kind of responses in your questionnaire is known as the nominal variable. Now this other one, we have ordinal data, in which the categorization, there is a meaningful order in the categories. The categories are not distinct, they are in inherent order. For example, okay, ordinal data makes a further distinctions by quantity of response alternative. Yes, ordinal variables show numerical differences between response alternatives. For example, we have what is your highest level of education? You can see that these responses are in inherent order. They are not really distinct. Less than high school graduates, some college graduates, then beyond college. These are examples of ordinal data in which there is a meaningful order in the categorization. So we also have this example here. How often do you discuss politics with your peers? And you see the responses here. When Anytime you are doing your responses in this form, you know that you are dealing with ordinal data very frequently, occasionally, rarely, never. So these are examples of ordinal categorization. They are quite different from nominal, that is either yes or no, male or female. Yeah, we have another popular ordinal data, which is the Likert scale. The Likert scale is one of the popular uh, ordinal data we use in sciences. They strongly disagree, neutral, agree, and strongly agree. So these are some of the um, types of data that you must know this you must know this data measurement for you to be able to analyze data very well, because the the categorization of your the categorization of your data or your data type is very important in choosing the analytical technique to use. So you must first of all make sure that you understand your data type very well. You must not be confused about the kind of data you are using at any point in time as a good data analyst. You must make that understanding. So one of the reasons why we do data analysis is because we want to do research. It is through research that we now begin to uh, collect data and do analysis of that data in order to in order to uh, come to a theoretical conclusion or empirical conclusion on the outcome of the research. So it is actually the research that give rise to data analysis, and it's so it's good that we understand research process. It's good we understand research process. I'm going to briefly go through these slides before I take us to the next uh, point where I want us to use the data. You know, we talk about research as yeah, we talk about research as a way of discovering how the world works around us. The main purpose of doing a research is to investigate the events that are happening around us, and find out the reason why things happen the way they do. And when we discover something that needs interpretation, that is what prompts us to make research. So something must make you want to find out how a situation works, so that we understand our environment better and the things that happen around our environment. So that is what makes us to go into research. And
in data analysis, there is how research is being done. You do research by developing a hypothesis. Now, that hypothesis is maybe a statement on how the researcher thinks that the variables are supposed to behave. That is your hypothesis. And normally, even in the law courts, what we do in research is the same thing they do in the law courts, where they investigate or make research on a case or an occurrence of an event. So you discover that in the law courts, they will first of all tell you that the accused person is innocent. In other words, that the accused person is not guilty. That is the point of argument in a law court. They will first of all start from the negative, that the accused person is not guilty. Now, the same way in research, we develop what we call the null hypothesis, which is a statement that contradicts the claim. A statement that contradicts the claim is that what you are looking for, that your claim, is not true. Just like they do in the law courts, they will tell you that the claim of the accuser is not true until the accuser brings enough evidence to convince everybody beyond any reasonable doubt that his claim is right. So that is their own null hypothesis in the law court, that the accused is not innocent. But in research here, we state a null hypothesis that the claim that whatever you are trying to find out is not true. So that is the starting point of data analysis in statistics. Once the researcher has this data, he can then conduct the appropriate statistical tests to evaluate research questions and the hypothesis. So we are going to take a survey here. This survey is about the money spent, college students spend buying recharge card, and possible factors that might influence student recharge card expenses. Now, our claim here is that the male students tend to spend more money buying recharge card than the female counterpart. That is our observation. And sometimes your thesis topic can be your observation. Let's assume that you can rephrase this thing now, this your claim now, as a thesis topic. Your thesis topic can be what is the difference? What is the difference? Or you can say recharge card expenses of the male and female in so university. That can be a topic, an investigation of the recharge card expenses of students at so location. So if that one is your thesis topic, and that is where your claim is going to be, but you are going to develop a null hypothesis that will contradict that your claim that there is no significant difference between the recharge card expenses of the male and that of the female. You can also state it in another way by saying that the recharge card expenses of the male and female are the same. That means there is no difference in their recharge card expenses. It's the same. So that is your null hypothesis. Why your claim is saying that there is a difference that male students tend to spend more. So that is how the starting point of research, and you state your no hypothesis here. There is no significant difference between research expenses of male and female. Then the level of study does not have any significant effects on the number of hours a student spends making call. So right now, we are going to go over to the research questionnaire. This is how you develop your questionnaire in case you are this is how you develop your questionnaire in case you are you are looking based on your research hypothesis. Based on your research hypothesis, you can easily develop your questionnaires. And here, my first question here is, how much do you spend buying recharge card per week? What is your gender, male and female? And this, what is your level of study? On average, how many minutes do you spend making calls per week? So these questions are going to help us to answer those hypotheses. Go over to Stata to upload this our data here into Stata. We are going to see how we are going how to manipulate the Stata interface and upload your data into Stata and be able to do your coding. That's going to be very important. But before then, I want to let us know the different stages of data analysis we're going to have here. If you were in the SPSS class, I told you that for you to do your data analysis of your research, you are going to have to do two different types of research. The first one is the descriptive statistics, and the second one is the inferential statistics. So I'm going to go through the descriptive statistics, then I will also go through the inferential statistics, so that when we get to Stata, we can just be doing all this and straight. First of all, we have the frequency distribution table as one of your descriptive statistics analysis. Now, what the frequency distribution table does for you is that you have it will bring out the number of persons that responded on a particular question and distribute them by frequency. In other words, the number of persons that responded on each question. There are some departments that only use frequency distribution to do the analysis. They only use frequency distribution. So it's a very important aspect of analysis, knowing how to get your frequencies from your data. Um, the next one is the measure of central tendency. Now, this one has to do with summarizing the distribution of the variables to see their mean value, the mode, and the media. The mean here is the average, the mathematical average of all the values in the distribution. That is the sum of the values of all cases divided by the total number of cases. So we have also the media, the midpoint of the distribution. Then the mode is a category of value that contain the most cases. So that's known as the central tendency. We're going to see it as we go into the software. Then the next one is the center as the measure of dispersion. The measure of dispersion or variability. This is the amount of spread or dispersion around the measures of central tendency. So the highest value for a variable. So you have the maximum, minimum, the range. These are all measures of variability from the central position. So we also have the variance that provide information about the amount of spread around the mean value. Yes. The amount of spread around the mean value is determined by the variance. And variance is the square root of the variance is the standard deviation. So most time we see the standard deviation in our result output instead of variance. It's because we normally use, it is better to use standard deviation for measurement, which is the square root of the variance. The variance measure is expressed in the unit of the variable squared. This can cause difficulty in interpretation. So more often the standard deviation is used because interpreting variance can be difficult. That is why most of the time standard deviation is used in our interpretation, which is the square root of variance. So that's for this. Then we have measures of distribution, the skewness and the kurtosis. Now, okay, we will soon go over to the software. Is anyone raising up hand? Please
yes, my hand is up.
Okay, please go ahead and ask your question.
Thank you, sir. So at this preliminary stage, we've seen the different steps involved in data analysis, the measure of central tendency, measure of dispersion, then the inferential statistics, as you've told us. Now, last time in our SPSS, we were able to see the application of, I think, the measure of the central tendency, where
this.
Okay, yeah, go ahead. So what I said is that all these things are descriptive statistics. They are just there to describe your data. So most of the time, you only tell us that this is what they are. For example, now, if I tell you that the mean of my distribution is so and so, maybe 3.4, That is just what it is. You are just, that's why it is called descriptive statistics, to get a feel and get understanding of your data. It's not that you are using it to interpret anything. It's most of the time where you do interpretation is you are inferential. That's why your mean is just there for information purposes, to tell you that this is the mean, this is the mean of this is the mean of your distribution. Now, I told you that uh, uh, variance is I told you that variance is um, the parameter that provide information about the amount of spread around the mean position, and which is represented most of the time using standard deviation. So standard deviation is the square root of the variance, which is also indicating the amount of spread around the mean position that is the amount of deviation from the mean position of that variable. So those things are just for descriptive purposes, just to tell you basic information about your data. That's why you do them first and then put them in your report, that your standard deviation, your mean mode is this. The maximum value, the minimum value, they are there. So there is a measure of dispersion, how the variability, how the spread around the central position. That is just what this measure tells you. So it doesn't have much implication in your interpretation most of the time. So the in your output, here you have your, why we always make reference to kurtosis is that this one measures distribution, which also indicates how skewed or normally distributed this particular your variation and your data is. So it helps you to also see how your data is distributed. This is distribution now, measures of distribution. So that is uh, the difference. Though there are some people in maybe education, most of them they use this descriptive statistics. They use their descriptive statistics to do their they read more meaning in the descriptive statistics of their data, where they try to compare the mean of different outcome. So the one that has the highest mean and the one that has the lower mean can become they can interpret based on their mean, based on the variable that has a higher mean and the one that has lower. So all those ones can also be used in in, uh, in their own analysis based on the way they do their own analysis, especially in education. Uh, so, but all you need to know is how you can get all these things out from your software and describe your data based on their uh, their basic properties. So I talked about the index of skewness. Take the value of 0 for a symmetrical distribution and negative value indicate negatively skewed distribution, and a positive value indicates a positively skewed distribution. Then we also have the kurtosis, which is if it is flat, it's a negative distribution. If it is peak, is positive distribution if y a here is the normal distribution. So then we have the inferential statistics. The inferential statistics here, we have, which is now the hypothesis testing. You use your inferential statistics to do your hypothesis testing. Those hypotheses you have stated, you can now use them to use any of these ones here. You can use any one here to analyze your hypothesis based on the kind of data you have in your hypothesis. So we can use independent t-tests, analysis of variance, chi-square tests, correlation, and the regression. So these are the popular ones here. Independent sample t-tests. Okay. Okay, so let me see if I'm going to, let me switch over to another. Okay, let me go ahead here because let me just finish this. So, the first analytical technique we are going to use to do our data, which is the money spent in recharge card data, we are going to use independent t-tests. And I told you that independent t-test assesses whether the mean of two groups are statistically different from each other. To properly conduct such a test, the following condition must be met. The first one is that you have a categorical variable that has two groups with a continuous variable, and it compares the two groups across the continuous variable to see if their mean differs. It also assesses whether any difference observed between the groups is due to chance or whether or not it is significant. So that is what independent sample t-test does for you, so that you'll be able to determine the difference in the groups. Okay, some of the assumption here is that the dependent variable must be continuous. Then the independent variable should consist of mutually exclusive groups. That's, they have to be categorical and mutually exclusive. In other words, they should be independent of each other. And all observations should be independent, which means that there should not be any linkage between observations. Means there should be no direct influence from one value within one group over other values in the same group. There should not be many significant outliers. This implies that the smaller the group. Okay, sorry. This implies the smaller the sample is. Okay. So here now, what they mean by outlier is that you are points that are too far away from the distribution. That's why we normally look at the distribution or the normality of the distribution. So there may be points that are too far away from others. That can become a problem when you when sometimes you observe that there are some points that are too far from others that could pose a problem, and that is a significant outlier. So you need to investigate the outlier to know whether it's an error, or maybe you try to uh, repeat the measurement to see if you can get something different. So the dependent variable should be more or less normally distributed. The variance between the groups should be similar. Okay, so here we're going to see the procedure for dependent sample t-test. So I'm going to go over to, I'm going to start right now to see how we can
I have a question, sir.
Okay.
Yeah, you mentioned outliers, and the only solution you provide is that whether to check back at the data source to find out if that data is correct or not. But is that the only way to handle outliers? Could there not be any other way the software can do that?
The only thing outliers does is that it will distort your results. So that's why most of the time you check whether you have an outlier. That's why they say that your distance should not have. If you discover outlier and you feel that the point is too far away from your distance, the only thing you will do is that you either find a way to remeasure it, remeasure that particular measurement and see whether the outlier occurred as an error, or that is how it is. Because if you do the analysis like that, it's going to really affect your results, and you can, because of that, get a wrong um, result. Because
So sorry, sir, we are asking if there is a way the software could always detect outliers before the analysis, or is it after analysis we go back to the data set, or we do the cleaning and weed off outliers before analyzing? So
that's the cleaning. The cleaning is what I just explained now, that you need to find out whether the points there, for example, if you have 40 points now and then you discover that one is too far away from others. So the only thing is that you find a way to clean it. It's either you check whether it was maybe typographical error, or if you discover you cannot find any this thing, you may decide to discard it. If not, it's going to cause a negative or a different result to your result. That's why sometimes you can if you discover that that point is going to cause problem in your research, you can convert it to a missing variable, because a missing data, and the way we coded it in SPSS, where you have missing variable, you can put 999 there and use it, and use 999 to and convert that point as missing variable. If not, it may distort the real result of your analysis. So you can do all those cleaning and discover if you have outlier. There is nothing you can do with it in the software. You have to find a way to correct it first before putting it in the software.
Okay, sir. What about scaling the data? I found out we couldn't do that in SPSS. Sometimes we might be required to log the data or do some other things. So how do we get to know that in SPSS or on this, what do you call it, Stata?
You say what?
I said one way to handling that could be locking the data like the logarithm. So we couldn't do that. I don't know. You said
what? You say
the outliers.
One way is to make it what?
Maybe can we scale the data like in logging it, finding the logarithm? So I don't know if you can teach us how to do that in the Stata or the SPSS to find the logarithm, like logging the data before the analysis.
Those ones you are saying is when you are doing e-view. That is where you do all those logging of data. When you are doing secondary data, you don't do all those ones here in SPSS and Stata. Most of the time, what we do, what we do in SPSS is primary data gotten from survey, people's response.
Okay.
Yes, people's respond. The ones you log are all those secondary data we get from Nigerian Stock Exchange and all those Nigerian Bureau of Statistics, all those people in finance and accounting that do secondary data. Those are the ones we use if you have an outline.
So
okay.
So if we collected primary data and there are outliers or the data set is not normally distributed, so how do we handle the situation if data conversion is only done in secondary data?
So you have asked two questions at the same time. You said if you have outlier, if you discover an outlier now, you can take your data to Excel and find out where, as in the data that is too far from the other ones. Those are the ones you concentrate on. Any data, any point that you feel that this one is too far from others, that is an outlier. Is most of the time is one or two. But if you discover that that is how the data is, maybe the data is scattered, they are not together, you can be convinced that that is how the data is. You use it like that and do your analysis and get your result. But what I mean is that if you have maybe one point that is too far from others, you can either change it or find out whether it's typographical error. That's what I mean. It's not as if outlier is something that just maybe a point. Maybe if you have 40 points now, you have one or two that is, maybe others are 10, 20, 15, 18, 11. Why one or two will now be 55? So that is what I mean by outlier. So you can now check whether the 55 is typographical error. All those things are something you correct manually. It's not something you correct in the system. Those ones you check your outlier.
Yes, sir. That's it. That is what we are saying, and that is why it looked like I asked two questions. One on the side of the outliers, when you have very few of them that are completely different from the majority. But then in situation now when, as you said, you discover that majority or all the data are scattered. They don't take a particular pattern. In other words, that is where the normality of the distribution now comes into play. Do we just go ahead and accept it that way and begin?
Yes, if you are convinced that they are not outliers. Maybe you see that the data are so scattered in their distribution, and you know that they they are not outliers. You go ahead and do your analysis with it like that.
Sorry, sir. Yeah, still on the question that my colleagues asked,
Yes.
because we are very particular about that outliers.
Hmm.
Now, during cleansing of the data, you don't need to just remove or cleanse off that data, or you fit it, then the system will automatically identify the outlier, maybe remove it or manipulate the outliers.
That is what I'm saying.
Because if go ahead, sir.
Go ahead. You say what?
Go ahead, sir. You said what you are saying something.
Yes. As what I mean is that all those things are when you have discovered an outlier, right? Outlier is maybe 1 or 2 points that are too far from others. Is that not?
Yes.
So when you have discovered an outlier, sometimes if you use it like that in your analysis, it will distort, maybe 1 or 2 will distort your whole your whole analysis. You will not get the right result. So this research here, remember that you are the one that is conducting it. It's still you that is in charge of what and what. You observe that this is an outlier, you can find a way. Either you remove that point or you bring it as you convert it to a missing variable. If you have 150 responses and two are outliers, it doesn't stop you from using 248 to do your analysis. That's what I mean. You can now say that you can state it that 2 points are observed to be outliers and 148 was used for analysis. You also state it. That all those things are, you make decision based on your description. So it's something you should manually check if it's okay for you or not. You can remove it and use the other ones to do your analysis. So you can now say that your sample size is this, but 104 sample size is 148. So
okay, sir. Sorry, sir. If we're using SPSS now, because there's a provision in that SPSS that is made for missing
variable
data.
Data, yes.
Yes. Now, can we, if we have up to 150 data we have collected or respondent, now, if we are feeding the SPSS, do we need to indicate it under that variable?
Will now indicate, like if it is 2 that is outlier and you want to remove them or you convert them to missing variable, you now tell SPSS that particular two variable anywhere, you now use a number. In SPSS, we normally use a number. Maybe you can say, you can put 999 or any number you like in those spaces that you think is outlier, and tell SPSS that those numbers are missing numbers. So you can now, SPSS will not use it in the analysis. They will just be there as dummy. So that's how it's something you use based on your description. On your description to know whether you are going to allow it or you use it. So that's how you handle outliers. You can decide to remove them, or you can go back and recheck your data to know whether it's typographical error or something. It's not for you to try and clean up and make sure everything is fine before you now put it in the software. So it's a decision you can make on your own, based on your own understanding of the data you are doing. You self that is doing research, you should have expectation of what you are supposed to have if you are doing primary data. So when you see an outlier, you should be able to know that this one is abnormal or something. So that's what I'm saying. You use your own.
Okay, sir.
Yes.
So if I understand you very well, you are saying that SPSS and Stata are primarily for primary data.
Yes.
Okay.
We have time series data. That is the ones we apply in eView. Time series data.
Yes.
Yes, most of them are the secondary data, and that's why every software has its own specialization. People in finance, most of them, they do primary data, secondary data purely. Even some um, economics and accounting. So all those ones, they do econometrics, where they have panel data, time series, and all the other distance. So that's where, but SPSS and Stata is more of primary data. You have to do your survey, and you are now analyzing your data using all this. So when you have outlier, it's easier for you to know why it is an outlier and investigate it. If you are not convinced, you may decide to remove that particular point to avoid distorting your data or your responses. Okay, this is our starter output here. This is our starter output. So we have this, and I'm going to go through it and show us how we can upload our data and do some other things. Okay, so
Please, can you zoom out your window? It's looking so tiny. Can you zoom out your display?
No, this is how it is. This you can't zoom this. This is the starter interface. You will see it. It's the writing is very small here, but you will see it.
The table can this thing can be zoom off. You can zoom up.
I cannot zoom here.
It can zoom. This is not the
go to where you have minimized. Where we have minimized, then the next one is to zoom.
This is how the software enter. Even me that I'm in front of the computer is tiny itself. No worry, you will understand it when you. First of all, what we're going to do now is to upload our software. We are going to, upload our data, not software here. We are going to upload what data do we do, sir? I will just show us briefly on how to upload the this, then I'll go back to another slide. So here we have.
So the Stata do we still use the SPSS or is it a different software?
It's a different software now. This is a Stata now. It's a different software.
And
Okay.
Kenneth, do you have the software?
Yeah, I have it. Only that I don't know if it is outdated now.
I don't have it.
You have it now, right?
No, I don't have it.
Okay, so after this class, you can send me your Telegram link so that I will forward it to you. Most of these softwares, Google can hardly allow it to be transferred because they say it's virus. But let's see. If I want to upload my data, I'm going to go from my file. From the file, you will see Excel spreadsheets, SLSS. So I'm going to click because my file is an Excel spreadsheet. So I have this. So I have Excel file. I'm going to browse. If I click on browse, I will locate my Stata. Okay. So I have I've uploaded from imports. You come to this export. So sorry, I'm supposed to click on import. Where is it? Import. Sorry. So we have now look at the preview here of our data. You see the heading of our data. So this heading now, I want if I click import first row as variable name, if I click on it now, all these things will become the variable name instead of ABCD. This ABCD will go off if I click on this because I want money spent on a recharge card, gender, LOS, and this one to be the name of the variable. So I will click on it. If I uncheck this thing, it will now take my variable name as row 1, and that is not what I want. So I want a situation where I'm going to have my variable name as the variable name. So when you click on this, you click on OK. So when you click on OK here, you have your command here written. So every command you type in Stata, this is where you type your command, and as soon as you run the command, it will show you on the display here. So this place here is like a display, and here is where the command is recorded. So it will be showing here while you are typing. So this is where you type your command in Stata. Is where you type. Then the variable names will show here and their label. So as soon as you upload data which I have uploaded, the variable names and their labels will show up here. Now we have these menu bars here. We have all these menu bars here. If I want to see the data I just uploaded now, I will go to data editor. You will see data editor, and your data editor will show. I don't know if you are seeing my data editor right now.
Yes, sir.
You are seeing this?
Yes.
Okay. So we have this is the data I just uploaded from Excel now inside Stata, and we are going to do some manipulation here because you discover what we did in SPSS. We need to make sure that we